NAFS 17 testing requirements for architectural grade aluminum windows. Welcome to Building Knowledge 101. In this video, we will discuss NAFS 17 testing requirements for commercial aluminum windows.
Now, some of the testing I mentioned, let's look at that so you have an understanding of what this testing is. So NAFS 17 and ALMA 910 talk about uniform structural load testing. So this is conducted in accordance with ASTM E330. You've seen that in curtain wall and storefronts test. But we're taking our structural design pressure, we're applying positive loads for 10 seconds and then negative loads for 10 seconds. So your structural test is again 1.5 times what design pressure of the product is. After that structural test, we're going to look at the product, make sure there's no damage to the fasteners, to the hardware, to any of the operating configurations, no deformment of the sash and the frame, the glass is not broken. So we're going to evaluate how the window is held up to that structural test. So when you look at our different performance grades across the top, from residential, light commercial, commercial window to AW, residential and light commercial are smaller windows, so there's no deflection limitation on that. They're typically smaller, so they're not going to bend that much. When you move to commercial windows in AW, these are much larger windows, and you'll see that when we look at the gateway sizes. So now we're concerned about deflection. So deflection is limited to L over 175 in both those categories. And then there is an allowable permanent set. So you can see with residential and light commercial, we're a little more relaxed there, and we're allowing 0.4% permanent set. So we're allowing those to bend and maintain a permanent set, a little bit more so than commercial windows, which is 0.3%, and AW is very strict. You're only allowing 0.2% permanent set. So the window can bend just slightly, but it's very, very strict on the AW side. Then water penetration resistance testing. Again, this is for all the windows, but what I want you to notice here is for residential, light commercial, and commercial, it's tested at 15% of the positive design pressure, yet for an AW window is tested at 20% of the positive design pressure. So again, if you're looking at AW windows, they are tested to a higher standard than all of the others. So again, we're looking at our layout of performance grades across the top, and you can see for residential, LC, and commercial is 15% of the design pressure, yet for AW it's 20%. And what the test is, it's a 24-minute test where you go through 4 cycles of applying the negative pressure to the window for 5 minutes, then release it for 1 minute, then apply it for 5 minutes, release it for 1 minute, apply it for 5 minutes, release for 1, and do that for 24 minutes, 4 cycles. All the time water's being sprayed on the window on the exterior. And the goal there is to measure with the negative air pressure being applied on the inside, is water penetrating the building? Is water penetrating through the window? So again, you can see then that with an AW window is 20% of the design pressure. So if there was a DP 40, then the negative pressure on the inside is going to be 8 pounds negative pressure, where with the others it's only going to be 15% of the design pressure. And then forced entry testing, I mentioned this earlier. Windows are subjected to people trying to break into them, trying to pry their way in, force their way into them. So forced entry testing is done to try to see if the window sash can be separated from the frame far enough that somebody can access hardware. Can someone get the sash far enough out that they can operate the hardware? If someone does force the window open, will it close? Will the hardware still continue to work? So with forced entry testing, the force is applied between the sash and the frame, and then the hardware is cycled and tested to make sure that it still operates and performs as intended. If the hardware does not engage, does not hold the window closed, or is not properly functioning, then it's a failure. So it's a pass-fail test there. NAFS 17 also looks at air infiltration and exfiltration and measures with an applied pressure difference on the window, measures the amount of air moving through the windows, measuring cubic feet per minute squared. Now, there's different types of windows. There's sliders and there are windows that work in compression. So you can see on the left side, under air pressure differences, I do have 2 different windows called out. I have sliders and compression because they're each tested a little bit different. But as you move across this chart to the right, what I again want you to notice is under the AW performance grade is tested to a higher standard. So AW windows are really differentiated, set aside from the others by having much higher design standards and testing standards applied to them. Operating force codes such as ADA require that windows have a maximum operating force. So this is very important that all through this time, we're measuring the operating force of the window. How much force does it take to break the seal of the window, start it moving, and then pull it back close and engage the frame and lock it again. So we're measuring the operating force of the window at each of those stages, breaking its seal, swinging open, then coming back and closing. Also the latching force, we're measuring the force applied there. If a window starts to bend or get damaged, it's going to increase the operating force and increase the latching force. And we don't want that to occur over time. So those are constantly being checked. That is all we have time for in this video. If you'd like to watch more of our 101 video series, subscribe to our YouTube channel, Kawneer Company, Inc.